Everyone, in this video we are going to tackle the 2023 Kangaroo competition problems for the 5th and 6th grade levels. Let's get started. In question number 1, Bandar fills the rest of the table with the numbers up to 40 following the system shown. Which of the pieces shown could he cut from the table? Okay, we can solve this question by filling the numbers until we reach 40, but that will take a long time. So we can solve it in a different way. If we notice here, between each two numbers in two different rows, we have 8 as a difference between these two numbers. So between 1 and 9, we have 8, between 2 and 10, between 3 and 11, and between 4 and 12. So if we check the answers, all the answers start with 12. So we will start by looking at the square that contains the number 12. So here, if we add 8 to this 12, we will obtain here 20. Then if we added 1 here, so we will obtain 21. And then if we added 8 to this 21, we will obtain 29. So we will obtain this figure here with these numbers. So if we compare these numbers with the answers, we will see that C is the correct answer. In question number 2, matchsticks can be placed to build numbers as shown. For example, to build the number 15, one needs 7 matchsticks, and one needs the same number of matchsticks to build the number 8. What is the largest positive number that can be built with 7 matchsticks? Okay, so let's look at the biggest number here. The biggest number is 800. So for just 8, we need 7 matchsticks. So for the other two zeros, we will need extra matchsticks. So this one cannot be the answer. Now let's look at the second largest number here, biggest number. We have 711. So for 7, to build 7, we need 1, 2, 3. We need 3 matchsticks, plus we need for 1, 2 matchsticks, and we need for the second one here 2 matchsticks. So we have 7 matchsticks in common in total. So D is the correct answer. We don't need to check the rest of these answers because this one is the biggest one here, so we need the biggest one. So we will select D. In question number 3, which of the following shapes cannot be divided into two triangles by a single straight line? If we look at the answers we have in A, if we draw a line like this, we will obtain 2 triangles. In B, if we draw like this line, we will obtain also 2 triangles. Here also we will obtain 2 triangles. And in E also we will obtain 2 triangles. But in D, we cannot obtain any triangles by just drawing a single straight line. So D is the correct answer. Okay, now in question number 4, Mariam has a piece of paper marked as shown, which she folds to form a cube. Which of the following 5 cubes can she get from this paper? Okay, first of all, we have a rule in a cube that the two opposite faces of any cube cannot be seen at the same time. So we cannot see this face here, this one, and this face here at the same time. So that's why A is not correct. Now if we go and looked at B, so this one, this face, may be this one here. So let's mark this one as 1 and here 1. Now this one is 2 and this one is 2 here, so also correct. And the direction of it also correct. And let's now look at the third one here. So the third one here can be this one here. And if we look at the direction after folding the piece of paper, so also the direction is correct. So B is the correct answer. Now in question number 5, Khaled climbed from the bottom to the top of the cylindrical tower shown. The steps are all equal size. 9 steps are visible. How many steps are not visible? Okay, now let's assume we have this tower, just this part here. For example, it is divided into 6 parts. So for each one of them, we need 1 step, like 1 here. So the stair should be equal to the number of these squares here until we reach all of them like this. So here we are going to count the number of these rectangles here, which represent the height of this tower. So if we count them, we will obtain 21. So we need in total 21 steps. So 21 steps. So we have 9 visible steps. So if we subtract 9 from 21, we will obtain 12. So D is the correct answer. In question number 6, Lana has 5 circular discs of different sizes. She wants to build a tower of 4 discs so that each disc in her tower is smaller than the disc immediately below it. How many different towers could Lana build? Okay, to solve this question, let's at the beginning give a number for each one of these discs. For example, here 1, 2, 3, 4, and 5. Now, in order to solve this question, we are going to exclude each time one disk and build a tower using the rest of the disks. So, for example, if we exclude the number 1 here, so we are going to build the tower using this one and this one and this one and this one and so on. So we will have 5 towers in total, and B is the correct answer. Now in question number 7, the picture shows a parcel around which 4 steps labeled M, N, P, and the Q are placed. In what order from first to the last were the tapes placed? Okay, now to solve this question, we will write here, for example, before and after. Okay, and then let's look and compare each two tapes together. For example, if we look at M and Q, which one of them has been placed at first? So, of course, we have M at first, then Q. Now, if we compare P and Q, we will notice that Q has been placed at first, then P. Now, if we compare N and M, we will see that M is being placed after N, so we will put N before M. So we will have this order N, M, Q, P. So which of the answers satisfy this result? D is the correct answer. In question number 8, Amal has the 4 puzzle pieces shown on the left of the figure. Which pair can be combined to form the hexagon on the right of the figure? Okay, so we have 4 puzzle pieces. If we can notice here, 1 and 2 are similar to each other, so we are going to use just one of them. And also the same situation for 3 and 4, also we are going to use just one of them. Okay, let's look at the piece number 1 and try to complete the figure. So we will draw this line here, and then this line, and then this line. And we will continue here these lines. Now we have this part here, this piece. So if we compare this piece with 3 and 4, we will notice that 3 is the correct answer. So we will use 1 and 3 to construct this hexagon, and B is the correct answer. In question number 9, the grease circle with 3 holes punched in it is placed on the top of the clock face. The grease circle is turned around its center. Which 3 numbers is it possible to see at the same time? Okay, to solve this question, let's look at these 3 numbers here and see the relation and the difference between each two. So here between 1 and 5, we have 3 numbers in the middle. Also here we have 1 number. Now let's look at the answers and see which one is correct. So for A, we have 2 and 4, so we have 1 between them. So maybe this one can be the answer. But now let's look at B and D and E. In B, we don't have 1 as a difference, so this one can be the answer. Also in D, we don't have 1 as a difference. So also this one cannot be the answer. And also for E, E also cannot be the answer. Now we have just A and C. So between 2 and 4, we said we have 1. Now between 4 and 9, we have 4 as a difference between them. And also between 2 and 9, we have more than 3. So this one can be the answer. Now let's look at C. Between 4 and 6, we have just 5. So 1 as a difference between them. Now between 6 and 12, we have 5 as a difference. But between 4 and 12, so between 12 and 4, we have just 3 as a difference. So this one is the correct answer. Okay, now in question number 10, Jawad glowed the 3 pieces of paper shown. This one here, the green one, this green semicircle, and we have this 2 white quadrant of circles onto this black circle. So which of the following patterns could he not obtain? If we look at A can be obtained because if we put the gray at first like this and then the 2 white like this, so this one can be obtained. And the same situation for B, if we put the gray like this and then the whites, so this one also can be obtained. Now in C, if we can notice here, this one, the semicircle, the gray semicircle will be just cover this part here. So this part here is an extra part, so it cannot be covered by the gray semicircle, so C cannot obtain, and this one is the correct answer.